Deep in a limestone cave on a remote Indonesian island, archaeologists pulled a skeleton out of the ground in 2003 and stared at it in disbelief. An adult, fully grown, with fused adult teeth and a fully developed skeleton, standing barely 3.5 feet tall. Everyone in that room assumed they'd found a child. They hadn't. They'd found an entirely separate species of human, one that had lived alongside our own ancestors for tens of thousands of years, on an island so isolated it had bred its own miniature version of an elephant. Scientists nicknamed it the Hobbit. What they eventually pieced together turned out stranger than the nickname suggests. The skeleton, designated LB1, came from Liangbua Cave on the island of Flores, and detailed analysis published in Nature on October 13, 2005 showed adults of this species stood only about 106 centimeters tall, roughly 3 feet 6 inches, and weighed somewhere between 30 and 40 kilograms. That's about 75 pounds, packed onto a fully mature adult skeleton, not a growing child. The brain told an even stranger story than the height did. LB1's skull held a brain of just 400 cubic centimeters, roughly a third the size of an average modern human brain, putting it in the same range as a chimpanzee. For comparison, Homo sapiens today averages roughly 1,100 cubic centimeters. A brain that small on a skeleton that fully grown broke every existing assumption about what a functioning adult human relative was supposed to look like. Naming it took a while, and getting anyone to believe it took even longer. The tiny skull carried defined brow ridges, features absent in modern humans, and the individual had fully developed wisdom teeth, confirming this was an adult and not a child after all. Scientists formally described the find in 2004, calling it Homo floresiensis, and almost immediately a significant portion of the paleoanthropology community refused to accept it as a real species at all. Many researchers, including Indonesia's leading paleoanthropologist at the time, argued the skeleton was nothing more than a modern human suffering from microcephaly, a rare condition causing an underdeveloped brain, rather than evidence of a genuinely new species. Other competing explanations followed over the years. One team proposed the skeleton belonged to a human with Laron syndrome, a disorder causing pituitary dwarfism. Another suggested it might represent small-bodied Homo sapiens, similar to short-statured populations that later lived on the Micronesian island of Palau. The debate over whether this was a real species or a pathological individual dragged on for years, splitting the field almost in half. The physical evidence eventually tipped the argument decisively toward a genuine new species. Homo floresiensis showed a strange mosaic of features, some primitive and some surprisingly modern, including short legs relative to unusually long arms, large flat feet, primitive wrist bones that looked nothing like a modern human's, shrugged forward shoulders, no chin, and a receding forehead. A single microcephalic individual doesn't spontaneously grow ancient-looking wrist bones or arms proportioned like an entirely different branch of the human family tree, and LB1 wasn't alone. Excavations eventually recovered remains from at least 11 other individuals, all showing the same distinct combination of features, all dated between roughly 100,000 and 60,000 years old. A whole population, not a single unlucky individual with a rare disorder. So how does something like this happen at all? The leading explanation carries its own name: island dwarfism. The most supported theory holds that Homo floresiensis descended from a population of Homo erectus that became isolated on Flores roughly 1 million years ago, likely after rising sea levels cut the island off from neighboring Java. Once trapped there, that population shrank dramatically over hundreds of thousands of years, a well-documented evolutionary pattern where large animals isolated on islands with limited food and few predators evolve smaller bodies, since smaller bodies need less food and less territory to survive on. Flores wasn't a one-off case either. Pygmy elephants once lived on the same island, now extinct, and showed the exact same size, reducing adaptation under the exact same pressures. An isolated island squeezed two completely different mammal lineages, humans and elephants, into miniature versions of themselves through the same evolutionary logic working in parallel. A competing theory complicates that clean story considerably. Some researchers argue that Homo floresiensis actually shows features closer to Australopithecines, an older and already much smaller ancestor than Homo erectus, suggesting the hobbits evolved from something more ancient and already diminutive, rather than shrinking down from a large-brained Homo erectus population. Under this version, hominins somehow crossed the sea to Flores more than 1 million years ago, already small, and shrinking further simply reduced their energy needs even more in an environment where resources stayed scarce. Nobody has fully settled which origin story is correct, and both explanations agree on one striking point. Getting to Flores at all required crossing open water, a feat that raises its own uncomfortable question about how a species with a brain the size of a chimpanzee's managed a sea crossing that some Homo sapiens populations wouldn't attempt for hundreds of thousands more years. Whatever produced that brain, it clearly wasn't holding these hominins back the way you'd expect. A 2005 study found that the region of the prefrontal cortex tied to advanced cognition was roughly the same relative size in Homo floresiensis as in modern Homo sapiens, despite the overall brain being a third of the size. Despite that tiny brain and small body, Homo floresiensis made and used stone tools, hunted small elephants and oversized rodents, dealt with predators as dangerous as giant Komodo dragons, and may have controlled fire. Tool use specifically counts as a hallmark of higher intelligence within our genus, and finding it consistently alongside these remains rules out the idea that Homo floresiensis was simply an intellectually stunted offshoot, a creature standing barely past your waist, with a brain smaller than a modern toddler's, was outthinking predators built to kill things many times its size. Living on Flores demanded exactly that kind of resourcefulness. Fossil evidence from the same deposits shows Homo floresiensis shared its island with Komodo dragons and other monitor lizards, crocodiles, several species of the elephant relative stegodon, giant tortoises, and multiple sizes of rats, some grown unusually large in the absence of typical mainland predators. Hunting a stegodon, even a dwarfed island version, with hand tools while standing 3.5 feet tall requires either group coordination, serious tactical planning, or both. There's no version of this story where the hobbits survived through luck alone. Then, after surviving on that island for what may have been close to 1 million years, they disappeared. Digs and geological dating at Liangbua Cave show Homo floresiensis went extinct around 50,000 years ago, tens of thousands of years earlier than researchers originally believed when the species was first announced. Earlier estimates had placed their extinction as recently as 12,000 years ago, which would have made them the very last surviving human relative alongside our own species. The revised dating pushed that timeline back considerably. That revision matters enormously because of what else was happening in the region right around that same window. No modern human remains have turned up anywhere in the region dating back as early as 50,000 years, raising the possibility that Homo floresiensis had already gone physically extinct before Homo sapiens even arrived nearby. But the timing still sits close enough, uncomfortably close, for researchers to keep investigating a darker possibility. Some researchers continue to explore whether the Hobbits' disappearance, occurring suspiciously close to when modern humans arrived in the wider region, points toward a connection between the two events rather than pure coincidence. Volcanic activity on Flores offers another candidate explanation entirely: a documented eruption around the same era that could have wiped out a population already confined to a single small island with nowhere else to retreat to. Nobody has landed on a definitive answer. What's certain is that a population that had endured for hundreds of thousands of years, surviving dragons, hunting elephants, and outlasting nearly every environmental pressure Flores could throw at it, vanished within a narrow window that lines up disturbingly well with our own species' arrival. Step back and consider what this actually means for the human story. For most of the 20th century, the assumption ran simple: Homo sapiens showed up, and every other human-like species had already been gone for ages. Flores broke that assumption completely. A 3-foot-tall relative with a brain a third our size survived on a single island for the better part of 1 million years, hunted megafauna, used tools, possibly used fire, and shared this planet with modern humans far more recently than anyone had guessed before 2003. Somewhere on that island, a population that outlasted nearly everything else nature threw at it ran out of time within a few thousand years of us showing up next door. Whether that timing is coincidence or consequence remains one of the genuine genuinely open questions in human evolution, sitting quietly in a cave that nobody thought to fully excavate until the start of this century.